Today we talk about solving linear and three-dimensional systems. Let's start with the linear systems. This is basically a review of Algebra 1, but in order to move forward, we've got to do this. So you'll see here we've got a system. We want to solve that by substitution. We've already done some substitution stuff this year. You know y is equal to this quantity. Substitute it into this y in the second equation. We get 4x plus x plus 1 is equal to 6, so 5x is equal to 5 and x equals 1. And if x is equal to 1, we know y is equal to 2. And once again, you remember that what this is basically doing is it's mimicking an intersection of two lines at some point in space. And then we move on to solving a system by elimination. Because these are equations, whatever we do to one side, we have to do to another. And if we can get these two terms to match, then we can eliminate a variable. So if I multiply both sides of this equation by 2, we end up with a new linear equation of 4x minus 10y is equal to 12. And then I can take and add these two equations and eliminate my x variable. And the reason I can do this is because it's very similar to balancing both sides of the equation by adding. If the right side of this blue equation is equal to 12, even though this says 4x minus 10, it's also equal to 12. So I'm, in a sense, adding 12 to both sides of the equation. In doing that, I get 16, negative 16y, and 0. So I've eliminated a variable, and y is equal to negative 1. If y is equal to negative 1, I can go back to either of the two equations, plug my y value in, and get an x value. So I have 2x minus 5 times negative 1 equals 6. We end up with 2x equals 1, and x is equal to a half. And there is my point of intersection of the two linear equations. Next we move to three dimensions, and we're talking about x, y, and z. There's a number of ways we can do this. Some people are a fan of substitution. I'm personally not. What I like to do is I like to number my equations 1, 2, and 3, and then eliminate some variables along the way. I notice if I take equation 1 and add it to equation 2, I can eliminate my z variable. So I have 3x plus 2y is equal to 8. And then if I were to take equation 2 and subtract off equation 3, I can eliminate my z variable again. I could also take 1 and add it to 3 and eliminate my z variable. It really doesn't matter. Lots of ways to get these problems done. So I'm going to take 2 and subtract 3. That leaves negative 2x, negative y, z subtracts off, equals negative 5. So you'll notice now I have another two variable system, and I can use substitution or whatever method I like to get this problem solved. Let's go ahead and use substitution just for kicks. We've got negative 2x plus 5 equals y. Plug that into that equation for y. I get 3x plus 2 times negative 2x plus 5 is equal to 8. This gives me 3x plus negative 4x plus 10 is equal to 8. Therefore, negative 2 is equal to negative x, and x equals 2. Once I have x, substitute back in. Y then is equal to 1. And once I have x and y, I can plug back in and find z. So I'll plug back into the second equation up here. So I have an x value of 2, a y value of 1 minus z is equal to 7. So therefore negative z is equal to 4, and z is equal to negative 4. So I get a triple of 2, 1, and negative 4 as my solution. We'll have some application problems as well. and they vary. It's just a matter of setting them up and then solving the system. So let's just go ahead and set this up. It says we've got $1, $5, and $10 bills worth 96 bucks. Makes a comparison of having one more dollar bill, then she would have just as many $1 bills as $5 and $10 bills combined, and she has 23 bills in all. And we want to know how many of each does she have. The answer is listed here, so you can go through and do that problem on your own if you'd like, but I just want you to set this up and I'll assume you can solve it. So I have, let's call X being the number of $1 bills, Y being the number of $5 bills, and Z being the number of $10 bills. And that's equal to a total of 23 bills in all. Now I can write an equation that talks about dollar values. I have 96 total dollars, and that's equal to the dollar value of $1 bills, so that's just X, the dollar value of $5 bills, which is 5Y, and the dollar value of $10 bills, which is 10Z. And then it says, if I had one more $1 bill, so the $1 bills, the number of those plus 1, then I'd have just as many as $5 and $10 bills combined. Number of $5 bills is Y, number of $10 bills is Z. And that would be my three variable system that I'd have to go through and solve. Again, Algebra 1, Algebra 2 review. That'll do it for today. Write your lesson summary, do your My Math Lab, and we'll get back to it.